Most organizations hear more agents and assume more productivity. That assumption is comfortable. It's also wrong. More agents usually means more unmanaged authority, more automated side effects, and more places where accountability quietly disappears. This isn't an episode about features. It's about scale, risk, and an operating model that survives contact with reality. You'll leave with 3 failure modes that kill agent programs, the 4-layer control plane that prevents drift, and the questions executives should demand answers to. Now, start with the misunderstanding that causes the chaos. The foundational misunderstanding: agents aren't assistants. An assistant generates answers. An agent executes work. That distinction matters because execution creates state and state creates consequences. A co-pilot-style assistant can write a summary. An agent can open a ticket, change a permission, update a record, trigger a flow, notify a manager, and then do it again tomorrow because you told it that's the process. The system didn't help. It acted. Most enterprises keep talking about agents like they're chatbots with better prompts. They're not. The agentic model is tools plus memory plus loops. It takes a goal, it calls something, it evaluates the result, it calls something else, and it keeps going until it decides it's done. That loop is the real architectural shift. Here's the uncomfortable truth. Once you cross from answer generation to tool execution, you are no longer governing a conversation. You are governing a distributed decision engine that can mutate systems. Think about the things that were previously hard to do at scale. Not because they were technically hard, but because they required human friction. Humans hesitate, humans ask questions, humans get tired, humans escalate. Agents don't. Agents are obedient, they don't resist. They don't get that gut feeling that something feels off. They just run the workflow you gave them with whatever data and permissions you accidentally handed them along the way. And that's why the network of agents narrative should make you nervous. The marketing version is coordination, agents collaborating, handing off tasks, accelerating outcomes. The operational version is chaining. Agent A calls tool X, which triggers system Y, which wakes agent B, which requests approval from a person who clicks approve because the card looks legitimate, which then causes agent C to run a write operation that nobody can easily unwind. Actions, triggers, approval loops, chaining. This is not a linear flowchart, it's an authorization graph with automation attached. Now add scale. In the research you provided, the billions of agents prediction shows up. Fine, treat that as hype if you want. Enterprise reality doesn't need billions to fail. It needs dozens. It needs one department shipping helpful agents faster than anyone can catalog. It needs one vendor adding a pre-built agent that quietly brings its own connector strategy. It needs one maker discovering they can share something just to my team. And then it spreads because it's useful. Entropy doesn't require malice, it requires convenience. The foundational mistake is assuming that an agent is a feature you deploy. In reality, an agent is a product you operate. It has an identity surface, a permission surface, a data surface, a tool surface, and a behavioral surface. And if you don't define those surfaces deliberately, the platform will define them accidentally. Let's break down the assistant versus agent difference in a way that makes governance obvious. Assistants mostly create text. The worst case is misinformation, tone issues, or a bad summary. That's real damage, but it's usually reversible. You correct the output, you move on. Agents create side effects. Side effects are the point. They exist to change something. A ticket, a document state, a SharePoint permission, a mailbox rule, a Teams membership, an Azure resource, a Power Platform environment, a purchase request. Side effects are also what auditors and incident responders care about because side effects are evidence of authority. So when leadership asks, are agents accurate? Then the right answer is accuracy is not the primary risk. Authority is. Nobody gets fired because a bot wrote an awkward paragraph. People get fired because the bot did something and nobody can prove who authorized it. And this is where the open loop matters. Everyone wants the agentic decade. They want a fleet of digital workers. They want autonomy. They want scale. But autonomy without governance doesn't scale intelligence. It scales ambiguity. Over time, policies drift away from intent. Exceptions accumulate. Ownership changes. Service accounts multiply. Connectors proliferate. And every single one of those is an entropy generator. The program keeps moving, but the control plane erodes underneath it. So the first job in an agentic strategy isn't building smarter agents. It's deciding what the enterprise will treat as enforceable truth. If something can act, it must have an identity. If it can call a tool, the tool must be governed as infrastructure. If it can see data, the boundary must be defined and monitored. If it behaves strangely, containment must be fast and attributable. That's the mental model shift. Agents aren't assistants, they are automated actors inside your control plane. Next, define what agent sprawl actually means, without the marketing fog, and why it always shows up first as identity drift. Define agent sprawl without the marketing fog. Agent sprawl isn't we have a lot of agents. That's the poster version. The operational version is uglier. Uncontrolled growth across 6 things that are hard to inventory and even harder to reverse. Identities, tools, prompts, permissions, owners, versions. If you can't name those 6 for every agent, You don't have an ecosystem. You have a rumor. Start with identity. Every agent that can act needs some form of authentication path. If the enterprise can't point to a stable, non-human identity for that agent, then every action it takes becomes a debate later. Identity sprawl is the first crack in the foundation because everything else, tool calls, audits, containment, hangs off it. Then tools. Agents don't exist as pure language. They exist as a bundle of tool invocations, graph calls, connector actions, custom APIs, MCP tools, flows, web retrieval, code interpreter, whatever the platform exposes this week. Tool sprawl means you stop knowing what capabilities are available, where they're reused, and which ones became the unofficial standard because someone shipped them first. Then prompts and instructions. People treat prompts like documentation. They aren't. Prompts are logic. They are policy expressed as text, usually without change control. Prompt sprawl means the enterprise ends up with dozens of slightly different interpretations of the same rule. What counts as sensitive, what counts as approval-worthy, what counts as safe to share, what counts as authoritative. Drift isn't a bug here. Drift is the default behavior. Then permissions. This is where sprawl becomes expensive. Agents get access through the same pathways humans do. App permissions, delegated access, connector credentials, service principals, environment roles, SharePoint permissions, and the quiet, just give it contributor for now, moments that never get revisited. Permission sprawl is how a deterministic security model becomes probabilistic. One exception doesn't hurt. 1,000 exceptions becomes policy theater, then owners. Someone has to be accountable. Not the maker who built it, but the sponsor who owns the business outcome, the risk, and the life cycle. Owner sprawl looks like this. The agent is shared, it becomes popular, the original maker changes roles, and suddenly nobody can answer a basic question like, who approves changes to this thing? The agent stays live anyway. Of course it does. And finally, versions. Every agent evolves. New instructions, new tools, new knowledge sources, new connectors, new models, new guardrails. Version sprawl is what turns troubleshooting into archaeology. You stop debugging behavior, you start guessing which variant of the agent a user even hit. Now, how does this sprawl actually enter the tenant? It usually arrives through 3 vectors, and all 3 feel legitimate. Vector 1 is maker-led, the I built a helpful agent for my team story. It starts personal, then departmental, then someone forwards the link, then it becomes semi-official, and suddenly it's in a critical workflow without a review gate. Maker-led sprawl is fast because the platform is designed to be easy. Vector 2 is vendor-provided. Microsoft ships agents. Third parties ship agents. Internal platform teams ship starter agents. They're pre-built, they demo well, and they often arrive with assumptions baked in. Permissions, connectors, data paths, and tool contracts. Vendor-led sprawl is dangerous because it feels sanctioned. People stop asking what it can do and start asking why they can't have it. Vector 3 is marketplace and third-party integrations. MCP makes tool onboarding easier. That's the point. But the other point, nobody wants to admit, is that easier onboarding also means easier propagation of mistakes. One bad tool contract doesn't stay local. It becomes reusable. It spreads. And here's the hidden multiplier most organizations miss. Every agent adds surface area across Microsoft 365, Power Platform, and Azure at the same time. This isn't 3 separate platforms. It's one connected control plane with different admin centers pretending to be separate worlds. So agent sprawl doesn't just grow your AI footprint. It grows your identity footprint, your connector footprint, your audit footprint, and your incident footprint. You'll know you're in sprawl early when a new question shows up in meetings. Which agent should I use? That sounds harmless. It isn't. It's a productivity tax. It means discoverability is failing, duplication is happening, and trust is fragmenting. People stop using the ecosystem because it's noisy, inconsistent, and unpredictable. And once that happens, the next failure mode arrives on schedule: identity drift. Not because you meant to lose accountability, but because you scaled agents faster than you scaled attribution. That distinction matters. Risk 1, identity drift, when accountability collapses. Identity drift is what happens when an agent can take action, but the enterprise can't reliably prove which non-human identity performed that action, under what authority and with whose approval, and the collapse is silent at first. Because everything still works. Tickets still get created, files still get moved, permissions still get granted, people still get answers. The system stays productive right up until the moment someone asks the one question you can't afford to fumble: who did this? Not which user asked the question, and not which department owns the workflow. Auditors don't care about your intent story. They care about attribution, a stable identity, a permission chain, and an evidence trail. Identity drift shows up when actions get executed through anonymous pathways. Shared credentials, maker connections, inherited delegated permissions, or tool calls that log as some generic application context that nobody can map back to an accountable sponsor. Over time, the organization stops seeing agent actions as actions. They start seeing them as automation. And automation historically has been treated like background noise. That's a mistake, Because the risk isn't that the agent makes a wrong decision. The risk is that the enterprise can't prove it made any decision at all. Here's what incident response looks like under identity drift. Something changes in SharePoint permissions. A mailbox rule appears. A team's membership changes. A record gets updated. The user says, "I didn't do that." The admin says, "We have logs." The security team pulls the event and it points to a service account or a connector or a vague app identity used by 5 different agents, owned by nobody, sponsored by nobody, and documented nowhere. Now, the organization is no longer investigating a technical event. It's negotiating a narrative, and narratives don't survive audits. Auditors ask 3 basic questions, and identity drift makes all 3 painful. First, who performed the action? Second, under what authority did they have permission? Third, who approved that authority and when? If your answer sounds like, well, it was probably the service desk agent, you don't have evidence, you have suspicion. And the moment the business hears probably, the program freezes. Because that's the real consequence of identity drift. One visible incident can pause the entire agent rollout across the company. The patterns are depressingly consistent. Shared credentials are the classic entropy generator. Someone creates a bot account, shares it with a few makers, and calls it progress. It isn't, it's identity debt. Maker connections are the next one. An agent gets built using a person's delegated access, then shared, then used by others. The agent now acts with the maker's shadow authority until the day that maker leaves, changes roles, or gets their access removed. Then the agent breaks, or worse, it keeps working in partial, unpredictable ways. Then there's the service principle everywhere anti-pattern. A single app registration ends up powering multiple agents, multiple tools, multiple environments. It looks neat in a spreadsheet. In reality, it's a blast radius amplifier. One compromise, one misscoped permission, one forgotten secret rotation, and you've attached a privileged identity to a fleet. And the weirdest one is anonymous tool calls. Not anonymous in the literal sense, everything logs somewhere, but anonymous in the governance sense. The logs don't map cleanly to an owned, lifecycle managed agent identity. You can't answer basic questions like which agent invoked which tool on behalf of what workflow with what approval state. So the operational consequence isn't theoretical. It's immediate. You can't do containment because you can't decide what to disable without collateral damage. If 10 agents share one identity, blocking the identity blocks 10 business workflows. You won't do it. You'll hesitate. And that hesitation is how incidents become outages. This is why identity drift is the first catastrophic failure mode. Not because identity is important, because identity is the anchor that makes the rest of governance possible. No identity means no least privilege enforcement that holds over time. No identity means no reliable audit trail. No identity means defender detections that can't be tied to a specific actor. No identity means Purview exposure reports that can't be attributed to a responsible owner. In other words, you don't lose accountability in a dramatic moment. You lose it one convenient shortcut at a time. And when the shortcut becomes normal, the organization crosses an invisible line. It moves from a deterministic security model to a probabilistic one. That distinction matters. Next, map identity drift to Microsoft's enforcement mechanism, Entra Agent ID, and why Entra needs to be treated as a distributed decision engine, not a directory. Control plane layer 1, Entra Agent ID as the audit anchor. Entra Agent ID exists for one reason, to stop identity drift from becoming your default operating model. The rule is simple and it's non-negotiable at scale. If it can act, it must have an identity, not a shared user, not whoever built it, not the connector account. An actual non-human identity that the enterprise can point to, scope, monitor, and retire. Because the moment an agent can call tools, it is no longer a chat experience. It is an actor in your environment. Actors need identities. Identities need ownership. Ownership needs lifecycle. That distinction matters. Most organizations treat Entra like a directory, users, groups, apps, and the occasional service principle nobody wants to own. That's the comfortable framing. It's also incomplete. In architectural terms, Entra is a distributed decision engine. It sits in the middle of every authorization path continuously, and it enforces whatever you actually configured, not what you intended. And this is why Entra Agent ID is not another object in Entra. It is the audit anchor that lets you build an evidence chain around agent behavior. When an agent has a stable identity, the enterprise can answer the questions that stop programs from getting shut down. Which agent did the action? Which permissions enabled it? Which tool invocation executed it? And which human approved it, if approval was required? Without that identity, every downstream control becomes hand-wavy. So what changes when you make Entra Agent ID a first principle? First, least privilege stops being optional. At small scale, people tolerate sloppy permissions because the blast radius feels contained. At agent scale, sloppy permissions turn into repeated automation of your worst assumptions. The agent doesn't occasionally overreach. It overreaches consistently. Entra Agent ID forces you to define permission boundaries explicitly. what this agent can read, what it can write, and what it can never touch. And when teams ask for exceptions, you can finally see what they're doing. They're not requesting convenience. They're manufacturing an entropy generator. Second, accountability becomes a configured property, not a social agreement. Every agent identity needs an owner and a sponsor. The owner handles the build and maintenance. The sponsor owns the business outcome, risk acceptance, and funding. Those are different roles, and enterprises keep pretending they aren't. This is where lifecycle workflows matter. If the sponsor leaves, the agent can't be allowed to drift into orphan status. Orphaned agents don't retire, they rot. They keep their permissions. They keep being used. They keep producing incidents that nobody can explain. So the identity object needs lifecycle controls: creation gate, periodic review, reattestation, and deprecation. If you don't enforce that, agent products become zombie services. Third, incident response becomes containment, not politics. With Entra Agent ID, you can disable the agent identity without disabling the entire program. That sounds small. It isn't. That is the difference between we contained the incident and we paused all agents until further notice. Executives don't fund programs that can't be surgically contained. And now the subtle but critical part: Entra Agent ID doesn't magically secure agents. It makes security enforceable. It's the anchor that lets Purview exposure map to a specific actor. It's the anchor that lets defender detections turn into an action you can take. It's the anchor that makes tool usage attributable. Identity is not the whole control plane. Identity is the thing the other layers attach to. Here's the microstory every audit team recognizes. A service desk agent updates a ticket queue. A week later, someone sees a set of tickets reassigned incorrectly. Under identity drift, you get "we think the bot did it." Under Entra Agent ID, you get agent identity X, tool action Y, executed at time Z, approved by person A, using permission set B. That's not a better story. That's evidence, and evidence is what keeps the program alive. So treat Entra Agent ID as the starting line, not the finish line. It gives you attribution, it gives you boundaries, it gives you lifecycle hooks, it gives you the ability to disable one actor without burning the whole village down. But identity alone doesn't prevent damage. Identity tells you who acted. It doesn't limit what happens when they act. That's the next layer. And it's where most enterprises lose control. Tools define blast radius. Next, MCP as the tool contract that turns integrations into infrastructure, and why standardization can either save you or amplify mistakes at scale. Risk 2, data leakage via grounding plus tools. Data leakage in agent systems rarely looks like an attacker exfiltrating secrets. It looks like a helpful workflow doing exactly what it was configured to do with exactly the access it was granted, using exactly the data it was allowed to retrieve. Agents don't leak maliciously, they leak obediently. That distinction matters because it changes the post-incident conversation. If the organization believes leakage is an intent problem, it will keep buying more training, more awareness, and more policies written in PowerPoint. The system won't care. The system will keep following the configured pathways. Leakage happens at the boundary between grounding and tools. Grounding is where the agent pulls context: files, emails, chats, SharePoint pages, Confluence, tickets, CRM records, the knowledge base someone swore was clean. Tools are where the agent takes action: exporting, summarizing, sending, posting, creating, updating, attaching. If you overscope either one, the agent becomes a high-speed compliance incident. Here are the common leakage pathways, and none of them require someone to be evil. First, overbroad retrieval. Someone grounds an agent on the whole department SharePoint because it's convenient, or all of Teams messages because the agent feels smarter, or they use a connector that returns more than the task needs because nobody enforced a minimal dataset contract. The agent now has access to a blended pool of data with different sensitivity levels, different retention rules, and different audiences. Then a user asks an innocent question. The agent answers correctly. And the correct answer contains something that was never meant to be surfaced in that context. The agent didn't hack anything. It just retrieved what you let it retrieve. Second, cross-domain context reuse. This is the one people miss. Agents operate in loops and they maintain state across steps. That means content retrieved for one part of a workflow can bleed into another part, especially when you chain agents or reuse tool outputs. A procurement agent retrieves a contract clause. A separate write the email agent gets handed that clause as context. The email agent posts it into a Teams channel that includes external guests because that's where requests are handled. Everyone claims they followed policy. The system still leaked. The leak wasn't the model. The leak was the choreography. Third, tool outputs get treated as safe artifacts. Tools produce outputs: summaries, exports, spreadsheets, tickets, cards, notifications, file attachments. Those outputs then get reused as inputs elsewhere. If you don't carry provenance and sensitivity forward, the system quietly launders restricted information into unrestricted channels. This is where helpful agent design turns into helpful breach design, because the agent can do the dangerous thing with a polite tone. Now, the executive level trap in all of this is what happens after the incident. Leadership asks, why did the agent do that? And the honest answer is, because it worked as designed. That's when trust collapses. Not because the incident happened, incidents always happen, but because the enterprise realizes it didn't actually design enforceable boundaries. It designed aspirations. And aspirations don't survive scale. The most uncomfortable version of this is when the agent answers from the wrong policy source. Not a wrong answer, a correct answer from a non-authoritative source. This happens constantly in enterprises because available and authoritative are not the same thing. The agent retrieves the first relevant-looking document it can access. That document might be outdated, it might be a draft, it might be a local variant, it might be a wiki page someone updated during a fire drill, it might be a screenshot of a policy pasted into a Teams message. The agent then gives the answer with confidence. The user acts. Compliance inherits the blast radius. And when you investigate, you discover the agent never violated access controls. It had access, it retrieved, it responded. The failure was governance. You never told the system which sources are allowed to be truth. So when executives ask, how do we stop data leakage? The correct answer is not make the model safer. The correct answer is enforce the data boundary before retrieval and enforce the tool boundary before action and keep provenance attached to outputs. If you don't, you're just accelerating the wrong behavior. And this is why a tool contract matters. Because bespoke connectors and one-off integrations are where boundary enforcement dies. Every custom integration expresses its own assumptions. Every shortcut creates a new pathway. Every pathway becomes a leak candidate. A standardized tool contract doesn't eliminate mistakes. It makes mistakes visible, reviewable, and reusable in a controlled way. That's the transition. Identity tells you who acted, but tools determine what they can break. Next, MCP reframed as a tool contract. Integration becomes infrastructure, and infrastructure is the only thing that scales without becoming conditional chaos. And control plane layer 2. MCP as the tool contract. MCP is not a new connector type. That's the comfortable framing. In architectural terms, MCP is a tool contract, a standardized way for agents to discover capabilities, call them, and receive structured results. And that matters because tool sprawl is where governance goes to die. Every bespoke integration is a new snowflake. Different auth, different logging, different error behavior, different assumptions about what safe means. At 10 agents, you can survive that. At 100, you can't. At 1,000, you're not operating an ecosystem anymore. You're operating an accident. So MCP turns integration into infrastructure. It makes tools something the platform team can treat like a shared service instead of a per-agent science project. That is the actual value. Here's what most people miss. Standard tool discovery isn't about developer convenience. It's about predictability. The system can't enforce intent if every agent calls a different implementation of create ticket or update record. You don't just get duplication, you get divergent behavior, and divergent behavior becomes inconsistent outcomes. In other words, decision debt. With MCP, the enterprise can standardize the verbs: create, read, update, approve, notify, export, and then govern those verbs like they're part of the control plane, because they are. Now, there's a tension here, and pretending it doesn't exist is how programs get hurt. MCP reduces bespoke chaos. It also makes mistakes propagate faster. When you build one custom connector wrong, you usually hurt one agent. When you publish one MCP tool contract wrong, you potentially hurt every agent that discovers and reuses it. That's not a reason to avoid MCP. It's a reason to treat MCP like production infrastructure, versioning, review, and blast radius thinking. So what does contract thinking actually mean? It means tools are enforceable interfaces, not developer shortcuts. An enforceable interface has 3 properties. 1, it's explicit about what it does, not in marketing language, in operational language. Does it read? Does it write? Does it delete? Does it create side effects that can't be undone? 2, it's explicit about what inputs it accepts and what outputs it produces. If the output is free text, you just created a laundering pathway. The next agent can't reliably know what it received. If the output is structured, fields, identifiers, source metadata, you can carry provenance forward and you can audit behavior later. 3, it's explicit about authority. Which identity calls it, with which permission scope, against which system boundary. If the tool can do privileged actions, then privileged actions require an approval pattern, not a policy document, a real gate. This is why MCP matters even when you already have connectors. Connectors get you it works. MCP gets you it works the same way everywhere, which is the only thing that scales. And this is also why MCP belongs in the control plane, not buried inside app teams. Tool contracts need central review because they define the blast radius of autonomous behavior. If you let every team publish MCP tools ad hoc, you didn't decentralize innovation. You decentralized authority. That's the same mistake, just with nicer JSON. So what should executives demand here? They should demand a curated tool catalog. Which MCP servers are allowed, which tools are exposed, and which actions are deliberately disabled. We enabled MCP is not a control, it's a headline. They should demand version control and deprecation rules. Tools change, APIs change, workflows change. If the contract changes silently, agent behavior changes silently. And that's how it worked last week turns into we can't explain what happened. And they should demand that every tool output includes provenance. If a tool returns policy guidance, it must return the policy source identifier, version, and timestamp. If it returns a ticket action, it must return the ticket ID and the actor identity that executed it. Otherwise, you're building an ecosystem that can't prove its own actions. Now, the boundary problem doesn't go away just because tools are standardized. A well-governed tool can still retrieve the wrong data if the data boundary is weak. And a well-governed tool can still leak if the agent can read too much. So MCP reduces bespoke chaos. It does not prevent obedient leakage. That's why the next layer exists. Purview DSPM for AI, not as a compliance dashboard, but as the data boundary that decides what agents may see and what they may never bring back. Control plane layer 3, Purview DSPM for AI as the data boundary. Purview DSPM for AI exists for a reason most programs try to skip. Governance law, you can't govern what you can't see. Identity tells you who acted. MCP standardizes what they can do. But neither one answers the question that actually determines whether your agents become a leak factory. What data did they touch? What did they retrieve? And what did they return? At enterprise scale, we think it only used approved data is not a control. It's wishful thinking with a dashboard. Purview is the layer that makes data boundaries observable, not just in the classic DLP sense of don't share credit cards, but in the agentic sense. Where is sensitive data exposed to AI systems, which agents are accessing it, and which interactions create risk signals you can act on before the incident becomes a headline. This is the foundational misunderstanding with data governance in the agent era. Most teams try to govern the response. They let the agent read whatever it can read, then they try to prevent it from saying the wrong thing. That's backwards. If the agent is allowed to read it, the agent can leak it. Even if you block the output, you've still created an access pathway, an evidence trail, and an attack surface. The breach might not be in the response. It might be in the retrieval logs, the tool outputs, the intermediate state, or the downstream workflow that reuses the data. Blocking the final sentence doesn't undo that. So the boundary mindset is prevent reading when you must, not allow reading and hope you can sanitize later. This is where Purview becomes more than compliance theater. It becomes the system that helps you define 3 things the business never defines cleanly on its own. First, what data is sensitive, where it lives, and who is allowed to access it in the first place. That's the old problem. It's still unsolved in most tenants. Second, which data sources are allowed to be used as grounding for agents. This is the new problem. Allowed for humans is not the same as allowed for agents. Agents scale retrieval. Humans don't. A human opening a document is a single event. An agent can retrieve 100 related documents in a loop because the goal required context. Same permissions, totally different behavior. Third, what constitutes authoritative versus available. And this is the part that collapses trust. If your agent pulls policy from the most accessible location instead of the authoritative repository, you've just automated misinformation with a professional tone. Purview helps by giving you visibility and exposure tracking across the content plane and by surfacing risk signals tied to AI usage patterns. It doesn't magically fix your information architecture. It just stops you from pretending the architecture doesn't matter. Now, executives usually want one thing from Purview, reporting that maps to business reality. They don't want a heat map of labels. They want answers to questions like which agents access sensitive data, which users rely on those agents, and where policy violations are accumulating over time, because that's what determines whether the program scales or gets paused. So the practical framing is DSPM for AI as an executive dashboard for adoption, exposure, and violations, not as a monthly compliance report, as an operational control plane signal. And here's the important distinction to keep straight. Visibility is not enforcement. Purview can show you exposure, it can show you risk, it can help you classify and define boundaries. But if you stop there, you've built a better rearview mirror, not a safer vehicle. This is why Purview has to connect back to the other layers. Entra Agent ID gives you attribution, which agent identity performed the access. MCP gives you the tool boundary, which toolpath retrieved or exported the data. Purview gives you the data boundary, which content was sensitive, which sources were used, and whether the interaction crossed a policy line. And then you still need a layer that detects behavior drift over time because agents don't fail only through bad design. They fail through evolving usage. People probe them, people push them, people accidentally feed them the wrong context. Attackers deliberately do it. And the normal behavior of an agent changes as the organization changes around it. That's the part compliance teams hate, because it means the boundary is not a one-time design. It's ongoing entropy management. So the rule for this layer is simple. If you want agents at scale, you must treat data governance as a runtime boundary, not a documentation exercise. If you can't see what agents are touching, you can't defend it. And if you only try to govern what they say, you're governing the wrong surface. Purview gives you the visibility and the boundary signals to stop guessing. But visibility isn't defense. Behavior still drifts under pressure. Next layer, defender for AI, because at scale, security becomes behavior-based whether you like it or not. Control plane layer 4, defender for AI as behavioral detection. Defender for AI is the layer that forces the enterprise to accept a basic reality. Agent security can't be intent-based. Intent is what humans claim after something goes wrong. Behavior is what systems actually do. And once agents act through tools, across data sources, in loops, you're no longer defending a chat interface. You're defending an execution surface that changes shape every day. Because the organization keeps changing around it, that distinction matters. Most security programs are still built on a comfortable assumption. If you lock down identities and you label data, you're covered. That was already optimistic before agents. In the agent era, it's inadequate because the failure mode isn't only unauthorized access, it's authorized access used in unauthorized patterns. The same identity can be valid and still dangerous. The same tool can be approved and still abused. The same data source can be allowed and still produce a leak when combined with the wrong prompt at the wrong time. So Defender's job in this control plane is not to judge whether an agent meant well. It's to detect when an agent's behavior stops matching the enterprise's assumptions. That's what behavioral detection actually means in practice. It means looking for patterns that indicate drift, coercion, or automation gone feral, prompt injection attempts, tool abuse, anomalous access sequences, and why is this agent suddenly doing that? Events that don't show up in your design documents. Start with prompt injection, because it's the attack everyone will pretend is edge case until it's in their incident report. Prompt injection isn't magic. It's just an attacker or a careless user smuggling instructions into the context stream. The agent reads it as part of the problem, then follows it as part of the solution. If the agent can call tools, the injection isn't just about bad answers, it's about bad actions. Defender's role is to detect those attempts and raise signals you can act on. Suspicious instruction patterns, unexpected content shaping, and the characteristic ignore previous instructions style coercion that shows up in real attacks. Then tool abuse. Tool abuse looks like an agent calling a high-impact tool at an unusual time, at an unusual volume, or in an unusual sequence. A service desk agent that normally creates tickets suddenly starts updating existing tickets in bulk. A policy agent that normally retrieves one document starts pulling hundreds. An approvals agent that normally waits for humans suddenly chains actions without the expected checkpoints. The system isn't broken, your assumptions are. And those assumptions erode faster than your governance committees meet. This is why Defender for AI becomes mandatory at scale, not because Microsoft says so, because autonomous behavior plus human pressure creates misunderstood design omissions on schedule. People will ask agents to do things they shouldn't. Makers will add tools they didn't fully review. Vendors will ship updates. Somebody will paste the wrong thing into the wrong place. And the platform will keep operating. Security debt doesn't announce itself, it accumulates. Defender gives you a way to see the accumulation as it happens. The practical outcome executives should care about is containment, not containment of AI, containment of one agent identity, one tool pathway, one behavior pattern without shutting down the whole program. That's what keeps adoption alive. If the only response you have to suspicious behavior is disable Copilot or pause all agents, you've built a program that can't survive scrutiny. You've also trained the business to treat AI as fragile. They will stop investing the moment it causes inconvenience. Defender changes the playbook. With identity in Entra, you can target the actor. With MCP tool contracts, you can target the capability. With Purview signals, you can target the exposure. With Defender, you can target the behavior in motion. So when something goes wrong, you don't need a cross-functional war room to debate what happened for 3 days. You isolate the agent, you quarantine the tool, you roll back the permission boundary, you preserve the evidence trail, and you keep the rest of the ecosystem running. That's the architectural win. You stop treating incidents as existential. Now, there's a trap here too. If you deploy Defender without attribution, you get alerts you can't act on. You'll see anomalous behavior involving agents, but you won't have a clean identity chain to disable. If you deploy Defender without data boundaries, you'll detect leaks after they already happened. If you deploy Defender without tool contracts, you'll detect tool abuse without knowing which tool implementation was called. Detection without enforceability is just anxiety. So Defender isn't the control plane by itself. It's the last layer that makes the chain complete. Behavior signals tied to identities, tied to tools, tied to data boundaries, tied to actions you can actually take. And the reason it has to be the fourth layer is simple. Visibility isn't defense. Boundaries aren't enough. At scale, behavior drifts. Defender is how you see the drift early and how you contain it precisely before the drift becomes the forcing function that freezes the entire program. Next, connect the 4 layers into a single minimum viable control plane, Entra, MCP, Purview, and Defender, and why missing any one of them turns enforceable intelligence into conditional chaos. The minimum viable agent control plane, how the 4 layers interlock. Most organizations try to govern agents by buying one product, turning on one switch, and declaring victory. That is not how this works. The control plane is not a product, it's an enforcement chain. And chains fail at their weakest link, not their most expensive one. So the minimum viable agent control plane is 4 layers that interlock cleanly, With no gaps you have to explain later. Entra Agent ID for who, MCP for what, Purview for what data, Defender for how it behaves. That's it. 4 layers, not because it's elegant, because anything less becomes probabilistic. Start with the interlock model as a mental map. Entra Agent ID answers who is acting, not who asked, who executed, which non-human identity performed the tool call, touched the data, and created the side effect. MCP answers what is the agent allowed to do, not in philosophical terms, in verbs. Which tools exist, which actions are exposed, which actions are disabled, which outputs are structured, which ones carry provenance. Purview answers what data can the agent touch and what data can it return. This is the boundary layer. It turns we think it shouldn't see that into it can't read it, and it turns we hope it didn't use sensitive content into exposure signals you can actually review. Defender answers how is it behaving over time. Normal behavior becomes baseline, drift becomes detectable, abuse becomes containable, and the signals tie back to an identity you can disable and a tool contract you can restrict. Now here's what most people miss. These layers don't just stack, they depend on each other. If Entra is missing, you can detect and monitor all day, but you can't attribute. You can't prove who acted. You can't surgically disable one agent without collateral damage. You end up pausing the program because that's the only lever left. If MCP discipline is missing, you can have perfect identity and perfect logs, but your integrations remain bespoke chaos. Every agent calls different endpoints in different ways, outputs different shapes, and leaks provenance. Your incident response becomes reverse engineering, not containment. If Purview is missing, you can know who acted and what tool they used, but you don't know what they touched. You'll discover exposure after the fact, and your post-incident report will read like a guess. That's the moment executives stop funding scale. If Defender is missing, you can label data, scope identities, and standardize tools and still get burned by behavior drift. Because the environment changes, the prompts change, the agents chain in new ways, and your controls lag reality. Missing layers don't create obvious gaps. They create ambiguity. And ambiguity is where agent programs die. So what does minimum viable mean in operational terms? It means you can trace any agent action end-to-end as a single evidence chain. Identity, tool call, data access, behavior signal, outcome. Not screenshots, not a deck. Evidence. If a ticket gets created, you can show which agent identity created it, which MCP tool executed it, which data sources were read to ground it, and whether the behavior matched baseline. If a file gets shared, you can show the identity, the toolpath, the data classification, and the behavioral context that led to the share. If a policy answer gets generated, you can show provenance, which authoritative source was used and which non-authoritative sources were intentionally excluded. That is the control plane doing its job, enforcing intent at runtime. Now translate that into executive demands, because this is where teams love to hide behind partial compliance. Executives should demand proof of enforcement end-to-end, not per component checklists. Not we have Entra, not we turned on Purview, not we built an MCP server, not Defender is enabled. The demand is show the chain for a real scenario, pick a high-impact workflow, show the identity, show the tool contract, show the data boundary, show the detection and containment path. If any part of that is, we don't have that yet, then the program is not ready to scale. It can still experiment, it can still learn, but it can't industrialize. And one more uncomfortable truth, the control plane doesn't reduce innovation. It prevents innovation from turning into unbounded authority. Because the moment you scale agents, you are scaling decisions, not just answers. Decisions that mutate systems. So the minimum viable control plane is how you keep intelligence enforceable as it grows. Next, this stops being theory. Apply the control plane to real scenarios, spoken, concrete, and uncomfortable, starting with the one every enterprise thinks is harmless. An IT service desk agent that succeeds so quickly it triggers sprawl. Scenario 1 setup, IT service desk sprawl starts as a success. The first scenario always starts as a win. That's why it spreads. A service desk team builds one triage agent. It sits in Copilot or Teams or a portal, doesn't matter. Users type the same messy tickets they've always typed. VPN broken, can't access SharePoint, new laptop, password reset, Outlook is haunted. The agent cleans it up, asks the 2 missing questions humans never ask consistently, and routes the request to the right queue with a sane category and a clear summary. Ticket noise drops. MTTR starts to move. Leadership gets a slide that says AI reduced backlog. Everyone claps. The team that built it gets asked to do a roadshow. And that's where the entropy begins, because the next thing that happens isn't a security incident, it's success. The agent works well enough that other teams decide they need their own version. The endpoint team wants a triage agent optimized for devices. The identity team wants one optimized for access requests. The network team wants one optimized for Wi-Fi and VPN. The application team wants one optimized for our line of business apps. And each of those requests sounds reasonable. Each team optimizes locally. That's the core problem. Local optimization creates global inconsistency. So you end up with 5 triage agents that all claim to be the best way to open a ticket, each with a slightly different intake process, a slightly different definition of severity, a slightly different set of tool calls, and a slightly different idea of what resolved means. Now the user experience collapses quietly. Users start asking, which agent should I use? That question sounds like curiosity. It's actually the first sign that your service model has fragmented, because if an ecosystem is healthy, users don't choose agents. The system routes them. The system has intent. In Sprawl, the user becomes the router. And users route based on convenience, not control. Now add the orchestration failure. This is the part nobody diagrams until it hurts. One agent routes a ticket to the network queue. Another agent, seeing the same symptoms, routes a similar ticket to identity. A third agent auto-suggests a self-service fix that's correct for one environment but wrong for another. Tickets bounce. Duplicate tickets get created. Humans retriage the triage. And the thing you build to reduce noise starts generating noise in a new shape. The organization calls this teething issues. It isn't. It's the system doing exactly what you designed, decentralized authority without shared intent. Then ownership collapses because ownership always collapses in Sprawl. The original service desk agent had an owner, it had a team, it had someone who could answer for it. But the moment other teams clone it, fork it, or build their own, ownership becomes ambiguous. Who owns the user outcome when the wrong queue gets the ticket? Who owns the inconsistent answers when two agents contradict each other? Who owns the escalation path when the agent says resolved but the user still can't work? Nobody owns the outcome. Everyone owns their component. That's how enterprise systems fail. Now put a real failure moment on it. A user requests access to a restricted SharePoint site. The triage agent decides it's an access request, calls the tool, and creates the ticket. Another team's agent decides it can do better. It triggers an automated workflow that grants temporary access to unblock productivity because someone added that capability during a sprint and never removed it. A manager gets an adaptive card approval in Teams, hits approve because it looks routine, and the user gets access. Except the site contains sensitive content the user shouldn't have. Now you have an incident, and it's the worst kind. An incident created by helpful automation, backed by a legitimate approval executed through a toolpath nobody reviewed end to end. And when leadership asks what happened, you get 5 different answers. Service desk says, we didn't build that workflow. Identity says, we didn't approve those permissions. The team that built the second agent says it was approved by a manager. Security says, we can't tell which agent executed the tool call. And the business says, so are we pausing all agents? This is the lesson. Scaling agents without shared intent creates contradictory intelligence, not because people are incompetent, because the platform makes it easy to build local success that erodes global control. And once the service desk becomes the proving ground, sprawl becomes normalized. Every department learns the wrong rule. If you need a capability, build an agent. Not if you need a capability, design it as a governed service. Next, the uncomfortable part. What changes when you enforce identity and shared intent as non-negotiable? Scenario 1, remediation. Deterministic routing and accountable action. Fixing the service desk sprawl problem doesn't start with better prompts. It starts with making routing and action deterministic again. Not deterministic in the sense that every ticket looks the same. Deterministic in the sense that the enterprise can prove this agent did this thing through this tool, under this approval model with this data boundary, every time. So remediation begins with the simplest enforcement rule the organization avoided in the rollout. Every triage capability gets its own Entra Agent ID. Not one service desk bot account, not one shared service principal that powers 5 different agents, one identity per agent product, scoped to what it actually does. That's what turns incident response back into engineering. If network triage agent starts doing something wrong, the containment action is obvious. Disable that identity. You don't disable all automation. You don't pause Copilot. You remove one actor from the system and you keep operating. An Entra Agent ID also forces the ownership model to stop being theater. Each triage agent has an owner who can change configuration and a sponsor who owns the business outcome. If the sponsor changes roles, lifecycle workflows reassign sponsorship. If the agent becomes orphaned, it doesn't stay live by accident. It gets reviewed or retired. That is what run agent products looks like in the service desk. Next, tools. The sprawl pattern happened because each team built its own tool path. Different connectors, different flows, different create ticket implementations, different routing logic. So remediation requires MCP discipline, standard ticket actions published once, reused everywhere. One MCP tool for create incident, one MCP tool for create service request, one MCP tool for update ticket status, one MCP tool for assign to queue. And those tools return structured results, ticket ID, queue ID, urgency classification, and the source that justified it. Not free text, not vibes, outputs that can be audited and replayed. This is the quiet architectural win. Tool reuse is where cost and control become the same decision. You reduce duplicated work and you reduce duplicated failure modes. Now the routing problem. The only scalable routing model is one intake, one intent model, and explicit escalation paths. If you let every team invent its own intake, you guarantee contradictions. So the enterprise picks an orchestrator pattern, a single front door triage experience that decides which specialized triage agent to call. Not because the specialized agents are bad, because the user can't be your router. The system has to be. This is where deterministic routing shows up in practice. The front door agent collects a minimum payload, symptom, impacted service, user identity, and whether it's an access request, an outage, or a how do I question. Then it routes to exactly one downstream capability, and if the downstream capability can't resolve it, it escalates to a human queue with the payload attached. No ping pong, no duplicate tickets, no conflicting answers from parallel agents. Now apply data boundaries because service desk agents love to help themselves into trouble. Purview boundaries block access to sensitive queues and restricted knowledge sources. The service desk triage agent doesn't need HR case data. It doesn't need legal investigations. It doesn't need executive mailbox metadata. So it cannot retrieve them, even if a user asks. And this is where the organization has to stop lying to itself about least privilege. Least privilege is not a security best practice at agent scale. It's the only way to keep the blast radius finite. Finally, Defender, because even with identity and tool contracts, behavior drifts. So Defender for AI baselines the agent's normal operating pattern, volume of ticket creation, types of ticket actions, typical queues, typical time of day, typical user populations. When the agent starts manipulating tickets in bulk, or changing assignments unusually, or pulling sensitive artifacts, Defender raises a signal you can act on. And crucially, you can act on it without destroying the program. You block the agent identity, you quarantine the tool, you disable a single capability, the rest of the ecosystem continues. That's what containment looks like when the control plane is real. So the remediation isn't one big service desk agent that does everything. It's a small portfolio of agent products with enforced boundaries, identities you can disable, tools you can govern, data sources you can restrict, and behaviors you can detect. And when leadership asks, how do we scale this safely? The answer is no longer a promise. It's a demonstration. Show the evidence chain for one routed ticket, Entra identity, MCP tool call, purview bound grounding, Defender behavioral baseline, and the human approval step if the action is irreversible. Because once that chain exists, the service desk stops being the origin of Sprawl. It becomes the template for enforceable automation. Next, the part that still breaks even well-governed service desk agents, accuracy without provenance. That's where policy and ops knowledge turns into compliance fallout, even when the agents write Scenario 2 set up MCP-backed policy plus ops agent and the provenance problem. The second scenario is the one that makes leaders hate agents because it looks like competence right up until it becomes compliance fallout. A team builds a policy and operations agent. The goal is clean. Stop wasting senior people's time answering the same questions. What's the change window? What's the approved exception path? What's the retention requirement for this data set? Which policy applies to contractors? It's all reasonable, it's all repetitive, and it's all the kind of work that feels like it should be automatable, so they do it properly. They ground the agent on policy libraries. They connect MCP tools to pull live operational context from systems of record, ticketing, CMDB, maybe a configuration repo, maybe a risk register. They structure outputs, they add guardrails, they roll it out to a pilot group, and the agent performs beautifully. It answers quickly, it answers confidently, it sounds consistent, it even cites sources because somebody knew that citations matter. The organization relaxes, that's the mistake. Because the failure mode here isn't that the agent makes things up. The failure mode is that it retrieves the wrong truth from the right place. Here's the failure moment. A user asks a question that looks simple. Are we allowed to apply this policy exception for this scenario? The agent pulls the relevant text, summarizes it, and replies, yes, here's the condition, here's the justification, here's the process. The user follows the guidance. They implement the exception. Work continues. 2 weeks later, an audit or a compliance review happens, or an incident triggers discovery, and someone notices the exception was granted under an outdated policy version, or under a departmental policy that was never meant to be enterprise-wide, or under a draft that was published to a SharePoint site for review and never marked as non-authoritative, or under a policy that applies to internal employees, not contractors. The agent's answer was internally consistent. It was also wrong in the only way that matters. It wasn't authoritative. So now the organization has a governance problem that's hard to explain because nobody can point to malice and nobody can point to a bug. The agent did what it was built to do. Retrieve content it was allowed to access and produce a high-quality summary. This is why provenance is not a nice-to-have in the agent era. Accuracy without provenance is still risk. And enterprises confuse those two constantly because humans tend to evaluate answers by confidence and fluency. They don't evaluate by source authority unless they're already suspicious. Agents amplify that bias because they speak like they know. Now add MCP to the mix because MCP makes the blast radius bigger in a very specific way. The agent doesn't just answer from documents. It can also call tools that return policy-like data from operational systems. What's configured in production? What's the current exception state? What's the last change record? What's the active retention policy in System X? Those outputs look authoritative because they're live. But live doesn't mean governed. A CMDB record can be wrong. A ticket can be mislabeled. A config repo can contain legacy settings. And MCP doesn't validate meaning. It just standardizes access. So the agent becomes a synthesis layer that merges three categories of information that humans normally keep separate: written policy, operational reality, and tribal knowledge embedded in tool outputs. That synthesis is useful. It is also where compliance dies if you don't enforce which sources are allowed to drive decisions, because the user isn't asking for a bibliography, they're asking for permission, and the agent can accidentally grant it. Now zoom out to the executive implication, because this is where we'll iterate stops working. Trust collapses faster than adoption grows. You can spend 6 months building momentum, training users, rolling out capabilities, and getting teams comfortable. One Provenance failure resets the trust model overnight. The business stops asking, how do we use this? And starts asking, can we rely on it? Legal starts asking, can we defend it? And security starts asking, can we contain it? And leadership starts asking, do we need to pause expansion until we can prove control? This is the pattern that kills agent programs, not technical failure, but credibility failure. And credibility failure happens when the system can't prove that its answers came from the right authority. So in this scenario, the agent's correctness is a trap. It's optimized for helpfulness, speed, and clarity. But the enterprise needs a different optimization target: authoritative knowledge, explicit provenance, and enforceable boundaries that prevent non-authoritative sources from being treated as truth. That's the open loop to keep in mind. The remediation isn't make it more accurate, it's make it reliably authoritative. And that means the next rule has to become non-negotiable across the ecosystem. The agent must prefer authoritative knowledge over maximum knowledge, because maximum knowledge is just everything it can read. And everything it can read is where the compliance incident is hiding. Scenario 2. Remediation, authoritative knowledge, not maximum knowledge. Fixing the provenance problem doesn't start with better prompting. It starts with admitting what the agent is actually doing. It's not searching, it's compiling an answer from whatever it can reach. So the remediation rule is blunt. The agent must prefer authoritative knowledge over maximum knowledge, even when maximum knowledge feels more helpful, because helpful is what gets you sued. The first move is Purview first classification, and not in the abstract we labeled some stuff sense. The organization needs an explicit definition of what counts as authoritative for each domain: HR policy, security policy, operational runbooks, change management, finance procedures, legal templates. Authoritative means owned, versioned, reviewed, and intended to be relied on. If the content doesn't meet that bar, it can exist, but it can't be treated as truth by agents. That distinction matters because the enterprise already has massive amounts of policy-shaped content that is not policy: drafts, local copies, screenshots, meeting notes, wiki pages, and email threads. Humans can usually detect that difference because they recognize the context. Agents can't. They detect relevance, not authority. If you don't enforce authority, the agent will optimize for most relevant text, which is how a draft becomes a decision. So you classify authoritative repositories as authoritative. You mark non-authoritative repositories as non-authoritative. And you stop pretending that it's in SharePoint makes it official. Next is boundary enforcement. You don't just tag content and hope. You restrict what the agent is allowed to use as grounding. That means the agent's identity gets access to the authoritative sources, and it gets denied access to everything else by default. Not read everything and cite carefully. Deny by design. Because if the agent can read non-authoritative content, it will occasionally use it. Not because it's reckless, because it is obedient. Now, the second move is MCP discipline. And this is where most teams accidentally reintroduce the problem. Tools must return structured results with source identifiers. If the agent calls an MCP tool to retrieve a policy or an operational rule, the tool response can't be a paragraph of text that looks authoritative. It needs a schema, source system, document ID, version, effective date, and classification. If the result doesn't contain those fields, the agent can't prove provenance, and you're back to sounds right. This is also where you make outputs carry their own chain of custody. A policy answer isn't just an answer, it's an answer plus a receipt. The receipt is what makes it defensible. And no, citations aren't enough if citations can point to anything. A link to a SharePoint page that got moved, duplicated, or edited without governance is not provenance. Provenance means this came from the authoritative system of record at this version effective on this date. Then Entra enforcement turns that into a permission model that doesn't drift. The policy agent identity gets scoped to the policy repositories, not everything it can read. If teams want broader access to make it smarter, they're requesting the ability to blend authority with noise. That's not intelligence, that's a compliance incident with better grammar. And this is where the sponsor role becomes non-optional. Someone in the business has to accept the trade-off. Narrower knowledge, higher reliability. If the sponsor wants maximum knowledge, the sponsor is accepting maximum risk. That's the actual decision. Make it explicit. Now add defender monitoring, because even with boundaries, people will still try to bend the system. You watch for two patterns. 1. Unusual policy queries. If a policy agent suddenly starts pulling large volumes of content or probing unusual domains or repeatedly querying exceptions and bypass terms, something changed. Either a user is trying to game it, or the agent got new toolpaths, or someone fed it poisoned context. The system doesn't need to know which one first. It needs to alert and contain. 2. Mass retrieval. The fastest way to turn a policy agent into an exfiltration tool is to ask it for all policies related to X repeatedly and then export. If you can detect that behavior early, you can block the agent identity, lock down the tool, and keep the rest of the ecosystem running. And that's the actual remediation story. You don't fix hallucinations. You fix authority. You reduce the agent's reachable surface area to what you're willing to defend. You force every tool to return provenance in a structured way, and you bind the whole thing to an identity that can be contained when behavior drifts. What this actually means is the agent stops being a search engine for your tenant and becomes a governed interface to your official truth. And once you do that, trust grows, because trust has a mechanical basis. The system can prove where it got the answer. Next, the scalable pattern that makes this survivable across thousands of decisions isn't more restrictions. It's human approvals at the edge, where irreversible actions and sensitive domains get a final checkpoint without slowing everything to a crawl. Scenario 3. Set up teams plus adaptive cards for approvals at scale. Now the third scenario, because eventually every enterprise discovers the same limit. You can't scale agent autonomy into irreversible actions and pretend governance will catch up later. So the pattern that actually survives is boring, repeatable, and enforceable. Teams plus adaptive cards for approvals at scale. Not because Teams is magical, because it's where work already happens, and because the approval surface is the only place you can reliably insert human accountability without sending people into a separate portal. Nobody opens. Here's the setup. An agent doesn't decide. It prepares a decision. It gathers context. It normalizes input. It checks policy boundaries. It proposes an action. And then it stops. That stop is the entire point, because the enterprise doesn't need agents that can do anything. It needs agents that can do bounded things quickly, with humans approving outcomes when the action is irreversible, sensitive, or politically explosive. So the workflow looks like this. A user asks for something that has a real blast radius, access to a restricted site, an exception to a standard control, a new vendor on board, a mailbox delegation, a data export, a policy waiver, a routing override. The agent collects the missing fields that humans always forget: business justification, duration, impacted systems, requester identity, manager identity, and the relevant policy domain. Then the agent packages that into an adaptive card. And the adaptive card is not just nice UI, it's a constraint mechanism. It forces structured input. It prevents the sure go-ahead approval that arrives as free text with no evidence. It standardizes the decision shape, what was asked, what was recommended, what policy it maps to, and what the consequences are. And critically, it keeps the approver in the flow of work. No context switch, no hunting for a link, no separate approval portal with its own identity problems. It shows up where they already live: Teams. Now the failure mode this avoids is subtle: approval theater. Most organizations claim they have approvals, but the approvals exist as emails or as screenshots or as the manager said yes in chat. None of that is enforceable, none of that is reliably auditable, and none of that scales because it can't be correlated back to an action chain. Adaptive cards fix that by making approvals a first-class event in the workflow, not an afterthought. The agent sends the card to the right approver based on a deterministic rule. The approver sees a bounded set of options: approve, reject, request clarification. If they request clarification, the agent collects the missing information and resubmits. If they reject, the workflow ends with the reason captured. If they approve, the agent executes only the bounded action it was designed for. That's how it scales. Humans approve outcomes, agents execute bounded steps. And the reason this scales operationally is that it reduces context switching in the exact places where enterprises bleed time. Approvers don't want to read a paragraph, interpret it, and then remember what system they need to log into to do the thing. They want a decision interface that is one screen, 1 minute, and one accountable click. Adaptive cards give you that micro experience. Now the real payoff is the audit trail, because this is where the control plane becomes visible. With this approval pattern, an enterprise can produce a clean evidence chain per action. The agent identity that prepared the request, the user identity that initiated it, the approver identity that authorized it, the tool call that executed it, and the timestamp for each step. Identity plus approval plus tool call plus timestamp. That becomes the default. And once that is the default, you stop arguing about whether the agent should have done it. You have the record, you have the boundary, you have the accountability. This is also where the governance layers interlock without being abstract. Entra Agent ID. The agent has a stable identity that prepared the request and executed the tool call, MCP. The execution happens through standardized tools with structured outputs that record what happened. Purview. The agent can't include sensitive data in the approval context if the boundary blocks it, and it can't ground on non-authoritative sources without being allowed. Defender. If the agent starts generating approvals at a weird rate, or targeting unusual approvers, or chaining actions outside baseline, you detect it and contain it. So the approval surface isn't extra. It's the seam where enforcement becomes real. Now, one more uncomfortable truth. This pattern forces you to admit that humans remain the accountability layer. The enterprise can't outsource responsibility to a probabilistic system and then blame the system when it acts. Adaptive cards make that responsibility explicit and rootable, and the organizations that scale cleanly are the ones that embrace that operating model shift early. Humans lead, agents operate, systems learn. Next, that operating model, because the tooling doesn't save you if you still treat agents like side projects instead of products. The operating model, from build agents to run agent products. Most enterprises fail at agent scale for the most boring reason. They treat agents like projects. A project has a start date, a finish date, a handoff, and a slide that says delivered. Then everyone moves on and the system starts drifting immediately. Agents don't work like that. An agent is not a build artifact. It is a running product. It has users, behaviors, dependencies, and failure modes that evolve under pressure. That distinction matters because the moment the organization ships an agent and walks away, Entropy starts writing the roadmap. So the operating model has to change from build agents to run agent products. A product has ownership, it has a sponsor, it has a backlog, it has a deprecation plan, it has an evidence trail, and it has an explicit answer to the question executives will ask after the first incident. Who is accountable for this system's behavior? If you can't answer that in one sentence, you don't have a product, you have a liability. Start with the simplest rule. Every enterprise-grade agent needs an owner and a sponsor. The owner is responsible for the technical shape, instructions, tool contracts, identity scope, monitoring, and change control. The sponsor is responsible for the business outcome, why the agent exists, what decisions it influences, what risk it is allowed to carry, and what happens when it fails. Without a sponsor, the agent will drift toward whatever users ask for because that's the path of least resistance. And whatever users ask for is how you end up with agents that accidentally become policy authorities, data brokers, and shadow administrators. Then define lifecycle workflows that treat agents like employees with badges, not like scripts. Provisioning, identity is created, tools are approved, data boundaries are validated, monitoring is enabled. Operation, usage is tracked, behaviors are baselined, incidents are contained, outputs are reviewed for provenance failures. Change, tool contracts version, prompts update, model behavior shifts, connectors evolve, and someone signs off that the blast radius remains acceptable. Retirement, the agent is deprecated, access is removed, identities are disabled, and the registry records why it was shut down. If any of those steps are optional, they won't happen. Optional controls become folklore. Folklore doesn't survive scale. Now the roles. This is where organizations love to overcomplicate and call it governance. The required roles are minimal and non-negotiable: platform, security, compliance, and a business sponsor. Platform owns the shared services, the curated tool catalog, MCP contract discipline, publishing gates, and the registry. Security owns identity boundaries and behavioral detection. The Entra identity model, conditional access decisions, defender baselines, and containment playbooks. Compliance owns the data boundary, purview classification, authoritative source designation, and exposure reporting. The business sponsor owns intent, which outcomes matter, what's acceptable, and what isn't. If any one of these roles is missing, you will still ship agents. You will also ship contradictory authority. It will feel fast, it will also be fragile. Now comes the piece most organizations avoid because it forces transparency: a registry. A registry isn't a catalog that exists to look mature. It is the system of record for why an agent exists, who owns it, what it can do, what it can touch, and which tools it can call. It answers the user question: which agent should I use? And before that question becomes a productivity tax, it answers the auditor question: which identities exist and what are they authorized to do? Before that question becomes a program freeze. And it answers the architecture question: how many overlapping agents do we have that solve the same problem differently? Before decision debt becomes permanent. The registry mindset also forces the enterprise to define discoverability properly. Agents shouldn't be discovered by rumor and Teams links. They should be discoverable by purpose, data domain, and allowed actions, and every agent entry should state one uncomfortable truth plainly: the agent's boundary, what it will not do, what it cannot access, what requires human approval. Then comes the entropy law, because this is where governance becomes real. Exceptions accumulate. A team asks for just one more connector. A leader wants just this one sensitive site. A pilot needs temporary access that never gets removed. A tool needs write permissions because it failed once and somebody unblocked it to hit a deadline. Each exception is an entropy generator. Over time, the system drifts away from the original intent, not because anyone chose chaos, but because the platform allowed intent to be negotiated instead of enforced. So the operating model has one job: enforce assumptions at scale. Not by telling people to behave, by designing the control plane and the lifecycle gates so that unsafe drift is harder than safe iteration. And when the organization does that, something surprising happens. Innovation doesn't die. It gets rooted into patterns that are reusable, auditable, and containable, which is the only kind of innovation that survives the agentic decade. Risk 3, cost and decision debt, the slow burn failure. Cost is the risk nobody leads with, because it sounds like procurement, but it's the forcing function that kills programs after the first wave of enthusiasm. Security incidents pause you fast, cost pauses you permanently. And the ugly part is that agent costs don't show up where people expect. They don't show up as AI spend. They show up as a distributed tax across tokens, tool calls, premium connectors, additional environments, extra monitoring, and the one cost nobody budgets for: human escalation when the agent can't finish. So the enterprise thinks it's buying productivity. What it's actually buying is a new kind of runtime. Every agent you add becomes a consumer of compute, data access, and decision-making bandwidth. Not once, continuously. And because agents encourage more usage, because they make it easy, your program doesn't scale linearly. It scales with demand you didn't previously see because humans avoided the friction. Remove the friction and the request volume spikes. This is the token side. Every conversation is not a chat. It's a chain: grounding, retrieval, tool calls, summarization, follow-ups, retrieves, and sometimes multi-agent chaining. The user sees one answer, the platform sees a loop, then the tool side. Every tool call has a cost profile: API quotas, transaction charges, connector licensing, downstream system load, and audit storage. If you let agents call tools freely, they will call tools freely. Not because they're wasteful, because they're optimized to complete tasks, and completion often means try again with more context. Retries aren't free. They become the default. Now add premium connectors and licensing boundaries, because this is where finance starts paying attention. Teams build agents in Copilot Studio, connect to a premium system, and nobody remembers that one more connector has a bill. Or worse, it has a per flow, per run, per capacity shape that only becomes obvious once adoption grows. The platform didn't trick you. You just didn't model the cost per completed task. And that's the metric that matters, not cost per chat. A chat that ends in escalation is not a completed task. A chat that creates 2 duplicate tickets is not a completed task. A chat that retrieves 10 documents and still answers from the wrong policy source is not a completed task. Counting chats makes dashboards look good. It does not keep the program funded. Now, the second part of this risk is harder to see, and it's more corrosive: decision debt. Decision debt is what happens when multiple agents solve the same problem differently at the same time, with different assumptions and different tool chains. It's the agent version of shadow IT, except it doesn't just create duplicate apps, it creates duplicate answers. And duplicate answers create rework. A user asks one agent for the policy path. Another agent gives a different path. The user pings a human. The human picks one. Then the agent gets blamed anyway. That's not AI unreliability. That's an inconsistent system design. Decision debt compounds in 3 ways. First, overlapping agents create inconsistent outcomes. The organization spends time reconciling contradictions instead of completing work. Second, duplicated tool contracts create duplicated maintenance. Even when MCP exists, teams still rebuild because they can. That doubles cost and triples failure surface. Third, exception growth turns every special case into a custom path. Each custom path requires more tokens, more tool calls, more approvals, more monitoring, and more incident response. Exceptions aren't operational flexibility, they're recurring invoices. This is why cost and governance aren't separate conversations. Cost is governance failing slowly, and cost becomes visible when finance asks the only question that doesn't care about your architecture narrative. What are we paying for, and what are we getting back? The predictable trajectory is always the same. Phase 1, invoices are small, adoption is exciting, leadership is optimistic. Phase 2, usage grows, more agents appear, tool calls increase, and the first cost spike hits. Phase 3, someone panics. The program gets frozen, not because agents didn't work, but because nobody can prove which spend created which outcome, and nobody can guarantee the next quarter won't be worse. This is the slow burn failure. It doesn't come from one bad agent, it comes from unmanaged multiplication. And if you want a practical warning sign before the CFO does it for you, it's this: when teams can't answer, In one sentence, which agent owns which outcome, you already have decision debt. When you can't tie tool usage to completed tasks, you already have cost drift. When you can't deprecate agents cleanly, you've turned your ecosystem into a permanent subscription to Entropy. Next, the metrics that stop this from becoming a budget-driven shutdown. 4 metrics executives actually fund, because they translate enforceable intelligence into defendable outcomes. The 4 metrics executives actually fund. Executives don't fund agent platforms. They fund outcomes that survive scrutiny. So if you want the program to live past the first invoice spike, the first audit question, or the first incident review, you need 4 metrics that don't collapse into marketing. 4 metrics that force an evidence chain, not adoption, not number of agents, not hours saved from a survey. Metrics that map to operating reality. First, MTR reduction, mean time to resolution. This is the easiest executive win because it's measurable, it's already tracked, and service operations already feel the pain. But the mistake teams make is treating MTTR as a tool problem instead of a routing problem. Clean payloads reduce MTTR. Deterministic routing reduces MTTR. Standardized tool actions reduce MTTR. And the control plane is what makes those 3 things repeatable. A typical mature agent rollout that enforces routing and tool reuse sees MTTR drop in the 20 to 35% range on targeted workflows. That's not magic. It's removing retriage, removing duplication, and preventing tickets from bouncing between queues. And the executive story becomes simple. Fewer handoffs, less noise, faster closure. Second, request to decision time. This is where agents matter outside IT because every enterprise has decision loops that waste days. Access approvals, exception handling, policy waivers, change requests, vendor onboarding, procurement checks. The work itself isn't hard, the waiting is. Agents don't eliminate governance. They compress the latency, they collect the missing fields, they package the context, they route to the correct approver, and they preserve the evidence. So the measure isn't how many chats, it's how long it takes to go from request created to decision recorded. In well-governed approval patterns, it's normal to see a 40 to 60% reduction, days to hours, sometimes hours to minutes, because humans stop doing the administrative choreography. They just approve or reject with context already assembled. That's the difference between an agent that helps and an agent ecosystem that actually changes throughput. Third, auditability. This is the metric nobody loves until they need it. And then it becomes the only metric that matters. Auditability is binary. Either you can produce an evidence chain per action or you can't. Before, we think the bot did X. After, here is the identity, the approval, the tool call, and the timestamp. That is what keeps the program alive during scrutiny, because audits don't ask whether the answer sounded correct. They ask who performed the action, under what authority, using what data, with what approvals, and whether controls were bypassed. Auditability is where Entra Agent ID stops being an identity feature and becomes a survival feature. It gives you stable attribution. Purview gives you exposure context. Defender gives you behavioral signals. MCP gives you the tool path that can be inspected and versioned. So the audit story becomes a replay, not a narrative. And executives understand this immediately. If you can't prove it, you can't scale it. Fourth, cost per completed task. This is where most agent programs die, because teams report cost per chat, and finance asks the only question that matters: what did the chat actually complete? A completed task means an outcome that didn't require a second agent, a human retriage, a manual rework, or an incident cleanup later. If you don't define completion, you can't manage cost. The organizations that standardize tool contracts and reuse them through MCP often see 25 to 50% lower cost per resolved request on mature workflows, not because tokens got cheaper, because the system stopped paying for duplicated integrations, duplicated retrieves, and duplicated human escalation. And here's the thing that makes all 4 metrics credible. They aren't independent. MTTR drops when request to decision time drops because fewer things stall. Auditability improves when tool reuse improves because evidence becomes structured. Cost per completed task drops when routing becomes deterministic, because the system stops doing the same work twice. So the goal isn't to chase 4 dashboards. The goal is to enforce the control plane so the metrics fall out as a consequence. This is also why executives should demand that every agent product has a measurement contract before it ships, not "we'll measure later." What is the completed task? What is the expected MTTR change? What decision loop does it compress? What audit evidence does it produce by default? What is the cost per completion baseline today? If a team can't answer those questions, they're shipping an experiment. Experiments are fine, but experiments don't get enterprise rollout budgets. Next, governance gates that don't kill innovation. Because metrics without enforcement gates just produce numbers that lie. Governance gates that don't kill innovation. Governance gates sound like the place innovation goes to die. And that's not a branding problem. That's history. Most enterprises implemented governance as a slow approval queue run by people who don't own outcomes, don't understand the work, and don't carry the blast radius when something ships badly. So makers root around it. Shadow systems appear. Entropy wins. So the goal isn't to add gates. The goal is to add zones with different enforcement and to make the path from experiment to enterprise predictable. 3 zones: personal, departmental, enterprise. Personal is where people explore. The agent can exist. It can help. It can even be useful. But it can't publish broadly. It can't run autonomous triggers, and it can't be wired into high-impact tools. That's not punishment. That's containment. Personal experimentation stays personal. Departmental is where teams solve real work for a defined audience. This is where tool reuse starts to matter. This is where you enforce that the agent has an owner, a scope, and a clear purpose. Departmental agents can connect to tools, but only through reviewed contracts. They can read data, but only within defined boundaries. And they can ship faster because the controls are predefined. Enterprise is where the agent becomes part of the operating model. That means identity is non-negotiable, tool contracts are standardized, data boundaries are enforced, and defender monitoring is enabled. Not optional. Default. That zoning model is the first gate, where the agent lives, determines what it's allowed to do. Now, the second gate is the publish gate. This is where most organizations overdo it. The publish gate should be brutally short. 4 yes-no checks that map to the control plane. 1. Identity created. Entra Agent ID exists, ownership is defined, sponsor is defined, lifecycle is attached. If it can act, it has an identity. If it doesn't, it stays in the sandbox. 2. Tool contract reviewed. MCP tools are used where possible, and the actions are explicit. No mystery connectors, no bespoke endpoints that nobody can trace. And irreversible actions don't exist without an approval pattern. 3. Data boundary validated. Purview signals exist, authoritative sources are defined, and non-authoritative content is either excluded or marked as such. The agent can't become a search engine for your tenant by accident. 4. Monitoring enabled. Defender for AI is watching behavior. Baselines exist. Containment actions are defined. If something drifts, you can disable one agent identity without pausing the program. That's the publish gate. It doesn't ask for diagrams, it asks for enforceability. Now, here's the uncomfortable truth. Least privilege has to become the default, not the aspiration. At small scale, people treat least privilege like a best practice they'll implement later, after the pilot proves value. At agent scale, later is where incidents come from, so the gate is deny by design. Exceptions become explicit requests, time-bound where possible, and treated as entropy generators. Not because the organization is mean, because exceptions are the mechanism that converts deterministic controls into probabilistic ones. And once controls are probabilistic, you don't get predictable outcomes. You get conditional chaos. Now, the next gate, and this is where innovation usually complains, is human in the loop. You don't need approvals for everything. You need approvals for irreversible actions in sensitive domains. Anything that changes access, shares data, deletes records, updates authoritative systems, or triggers downstream financial impact needs a human checkpoint. And the trick is not making people jump through portals. It's routing approvals into the flow of work, using structured payloads, so the decision can be fast and accountable. That pattern scales. It also makes audits boring, which is the highest compliment an enterprise can receive. Now, how does this avoid killing innovation? Because gates don't slow teams when the gates are pre-baked into the platform. The platform team publishes the tool catalog. Security publishes the identity patterns. Compliance publishes the authoritative sources. Defender publishes the baseline and containment playbooks. Then makers build inside those constraints without negotiating them every time. This is the inversion most enterprises miss. Innovation dies when every project has to invent its own governance. Innovation survives when governance is a reusable service. And yes, you still allow experimentation. You just don't let experimentation become production by accident. So the governance model isn't no. It's you can do almost anything in the personal zone, some things in the departmental zone, and only enforceable things in the enterprise zone. That's how you scale intelligence without scaling chaos. Next, the realistic 12-month adoption sequence, because this doesn't land by buying licenses. It lands by moving in a deliberate order that keeps the program alive under scrutiny. The 12-month adoption sequence for the agentic decade. Enterprises keep asking for the agent roadmap like it's a feature checklist. It isn't. It's an order of operations problem. If you scale capability before you scale enforceability, you get sprawl. If you scale enforceability before you scale capability, you get adoption that survives. So here's the 12-month sequence that actually works because it matches how systems decay. Month 0 to 3, inventory and identity, not innovation theater. The first 3 months are about admitting what already exists. You already have agents, copilot prompts, power automate flows, scripted integrations, shared service accounts doing automation. The agentic decade doesn't start when you buy Agent 365. It starts when you measure the non-human actors already touching your tenant. So you inventory agents, tools, and automations by domain. You create the catalog structure. And then you mandate the one enforcement rule that prevents identity drift from becoming your first scandal. If it can act, it must have an Entra Agent ID. not later, now. And you attach ownership and sponsorship as part of creation, not as a cleanup project. If you can't name an owner and sponsor, it stays personal. It doesn't scale. Month 3 to 6. Standardize tools, then remove the bespoke connectors you already regret. This is where MCP stops being a developer topic and becomes a governance primitive. You don't let every team integrate. You publish a tool contract catalog. What actions exist, what the payload looks like, what the output looks like, and what provenance must be included. Then you do the unglamorous part. You kill bespoke connectors, not because they're evil, because they multiply your failure modes. Every bespoke toolpath is a separate incident response workflow you'll have to run at 2 a.m. That is not innovation, that's architectural erosion. At the same time, you set data boundaries in Purview that match reality. Classify authoritative sources, identify sensitive repositories, and make deny by design the default posture for agent identities. If a team wants broader data access, they're requesting a wider blast radius. Make that explicit. Month 6 to 9, baselines and containment, because drift starts as soon as adoption becomes normal. By month 6, the ecosystem starts behaving like an ecosystem. People reuse agents, chain agents, and ask agents to do more than they were designed for. The system doesn't stay stable. It accumulates pressure. So this phase is defender for AI becoming operational, not just enabled. You build baselines for normal per high-impact agent, tool call rates, data access patterns, unusual retrieval, unusual approvals, anomalous identity behavior. Then you write playbooks that contain one agent without punishing the entire program. Disable the agent identity, quarantine the tool, restrict the data boundary, force approvals, and resume. The goal is not perfect prevention. The goal is fast containment with evidence. Month 9 to 12, scale the approvals pattern and start deprecation like you mean it. This is where the ecosystem either matures or collapses under decision debt. The difference is whether you can retire agents cleanly. So you standardize the Teams plus Adaptive Cards approval surface for irreversible actions and sensitive domains. You make it a reusable pattern, not a one-off workflow. Humans approve outcomes, agents execute bounded steps, and then you do the part nobody wants to do. You deprecate redundant agents, because sprawl is not just too many. It's overlapping authority. If two agents answer the same policy question differently, you don't have optionality. You have inconsistency, and inconsistency becomes rework risk and cost. So you collapse duplicates, route users to the authoritative agent product, and enforce lifecycle. Build, publish, operate, retire. No orphaned identities, no abandoned prompts. No, it still kind of works. That's the 12-month sequence. Identity first, tool contract second, data boundaries third, behavioral detection fourth, approvals and deprecation as the scaling mechanism. And once that order is in place, the organization stops asking how many agents show. Conclusion: the advantage is enforceable intelligence. The agentic advantage isn't more intelligence. It's intelligence that stays enforceable when it scales under audit, cost pressure, and incident response. If you want the practical next step, watch the next episode on building an agent registry that prevents sprawl before it becomes your operating model. Subscribe.